I'm very quickly going to have a look at May 2008 C2 Circles question. It's question 8 off that paper. We've basically got 2 points, P, which is at 1, 4, which I've plotted, and I've got a point Q, which is at 9, 10, which I've plotted. You're told that these are at opposite ends of a diameter of a circle. So that there is a diameter, and you have got a circle like so. And obviously the centre of the circle, which is called point A, would be somewhere in the middle like so. Part A1 simply says write down the coordinates of the centre of the circle A. Okay, well, you know one point, you know another point. The centre of the circle is going to be halfway in between those 2 points. So what we're looking at is coordinate geometry C1 working at the midpoint connecting 2 given points. I've labelled this one x1, y1, that one x2, y2. So I'm going to use, the midpoint is called A, and I'm going to say it's going to be simply x1 plus x2 over 2, y1 plus y2 all over 2 from coordinate geometry work. So the midpoint A will be equal to, okay, x1 is 1 plus x2 is 9. Divide by 2, comma, y1 is negative 4, plus y2 is 10, all over 2. So a very simple calculation, the midpoint will be 1 plus 9 is 10, shared by 2 is 5, minus 4 plus 10 is 6, shared by 2 is 3, which I'll plot in the picture, 5, 3, 5 and 3 up. It's approximately there, 5, 3, label it x3, y3, that is the centre of the circle. So there's the diameter, there's the circle as it were, and the centre A, 5, 3. Okay, part 2 says work out what the radius is. A bit more coordinate geometry coming up now from C1 again. We know from A to Q is the distance between 2 given points, it's the radius of the circle. So if I just use coordinate geometry, distance between x3, y3 and x2, y2, x3, y3, x2, y2, the distance AQ is the radius of the circle. So AQ is equal to the radius, is equal to the square root of, it's x3 minus x2 squared plus y3 minus y2 squared. Simply substitute in the points. So the radius will be equal to the square root of x3 is 3, x3 is 5, 5 is x3, take away x2, that's 9, in a bracket squared, plus y3, that is 3, take away y2 in a bracket, up here, is 10 squared. So the radius is equal to the square root of, that's negative 4 in the first bracket squared, plus that's negative 7 in a bracket squared. So you get r is equal to the root of, I think you're going to get 16 plus 49, they're both positives obviously when you square them. So r turns out to be the root of 65, which is what we needed to show. So that's part 2. So we now know the length of the radius, root 65. Okay, part 3, write down the equation of the circle C. Well, if I know what the centre is and I know what the radius is, it's really simple to write down the equation. I'll do it here because I'm running out of space there. Part 3 then, the equation of C will simply be, you do it in the bracket notation, a bracket squared plus another bracket squared will be equal to the radius squared. If the radius is root 65, then we're going to get 65. Let me make some space here so you can clearly see the equation of the circle as it comes out. So that is the root 65 squared on the right hand side. If the centre is 5, 3, then the first bracket will simply be x minus 5, and if the second bracket needs to be found, look at the 3 there for the y coordinate. It's going to be y minus 3. And there you go. There's the equation of the circle. It's fine to leave it in the bracket notation. You don't expand it out. Leave it like that. Okay, that's part A done with 4 marks. Part B now talks about another point, R, which is 4, 11, which I'll plot. 4, 11. which is about there. That's R, 4, 11. For reference, I'll call it X4, Y4. And what we have to show is that R actually lies on the circle C. So we've got the centre, we've got the diameter, we've got this circle. We need to show that R lies on this circle. Okay, if I make some space, get rid of all of this to do part B. I'll leave that there because I'm going to need it. So part B. Okay, now obviously if you did a scale picture and you did the x-axis the same scale as the y-axis, you could get yourself a compass out and you could draw the thing and you could prove that point R actually lay on the circle if you wanted to. But you'd get no marks because it needs to be an algebraic proof. Okay, there's the equation of the circle. Any point that lies on that circle, if you substitute in the x and substitute in the y value into that equation, out will pop a true statement. Let me show you if you're not sure. What I'm going to do is take the left hand side of this equation. The left hand side of the equation of C. And I'm going to substitute into that x equals 4, y equals 11. And I'm going to work it out. Let's see what I get. Okay, so take that equation, put 4, 11 into that equation on the left hand side only. The left hand side will be equal to x minus 5. Well, x is 4. 4 minus 5 squared plus y minus 3 squared. That's 11. 11 minus 3 in a bracket squared. You get minus 1 squared plus 8 squared, which is 1 plus 64, which is 65. So the left hand side works out to be 65. But the right hand side is 65 as well. So we're getting a statement coming out which says 65 equals 65, which is a true statement. So the 65 is equal to the right hand side. So what does that mean? Therefore R, the point 411, must lie on C. And there you go. Yeah, there you've done it. 2 marks for part B. We've shown that R lies on C. Okay, finally we've got an angle to calculate. So I'll make some more space. Don't need this now. Get rid of all of that. So I've finally got an angle to calculate. It says find the angle Q to P to R. From Q to P to R. Well, that angle there, call it theta if you like. Well, Q to P to R. The key to this is to realise that if I join up from R to Q, I now create myself a triangle. It's not a right angle triangle, but I can use trigonometry, sine rule or cosine rule on it to get a missing angle. I already know from P to Q the distance because it's the diameter of the circle. We know the radius is root 65, so I do know from P to Q is 2 root 65, twice as much, obviously. If I could work out that distance there, and I could work out the distance from there to there, then I would know all 3 side lengths of that triangle. I can use the cosine rule to work out the missing angle, which is what I want. So that's what I'm going to do. I'm going to work out first of all the distance RQ. So part C, let's find out what RQ is. RQ is equal to, I'm going to use simply the distance between 2 given points formula from coordinate geometry C1 again. I know that's x4, y4, x2, y2, so I'm going to do x4 minus x2 squared plus y4 minus y2 squared equals, it's the square root of x4 is 4 minus x2 is 9 in a bracket squared plus y4 is 11 minus y2 is 10 in a bracket squared. You're going to get the square root of minus 5 squared plus 1 squared. That's the root of 25 plus 1, it's the root of 26 units. So I know in this picture now, across there is root 26 units. So now I know the length of 2 sides. Do a similar sort of thing now, very quickly. for p to r, and I'll know three sides. So p to r is equal to, coordinate geometry again, square root of. P and r uses x1, y1, x4, y4. So x4 minus x1 squared plus y4 minus y1 squared equals the square root of x4, that's 4, minus x1, that's 1, squared plus y4 minus y1. y4 is 11, minus y1, well, be careful, it's take away minus 4. So that actually becomes a plus 4. There's a double negative going on there, be careful. Squared. So this is equal to the square root of 4 take 1 is 3 squared plus 11 plus 4, that is 15 squared. So we end up with the root of 9 plus 225, and that's 234. A little hint in all these questions at A level, if you're getting various surd quantities coming out for side lengths, for example, and one of them is quite a big quantity, I would always look to see if it can simplify. And this one will simplify in the following way. You can change the 234 into 9 multiplied by 26. 9 26s are 234. Okay, and therefore that will be the same as root 9, root 26, which is 3 root 26. And that obviously sort of is similar to that sort of figure. They're both root 26s. Always look out for that because it can help in the simplification that comes later, possibly. So in this picture, I know that that is 3 root 26. I now know all three sides of that triangle. I can apply basic Year 11 cosine rule work to it to work out the angle theta in the picture, which is what I want. Okay, so to finish off, get rid of all this. Let's just choose the appropriate format for the cosine rule to use. I want theta, which is really corner P, so I want cos P to appear in my cosine rule formula. So I'm going to use for part C little p squared equals little q squared plus little r squared minus 2qr cos of big P. And I'm going to substitute in the values for this particular triangle. So little p squared, there's big P, little p is root 26. Root 26, I'm going to square it, is equal to little q squared. Well, there's big Q, so opposite it is little q over here. 3 root 26 is little q. So you get 3 root 26 must be squared. Plus little r. Well, there's big R in this corner here, big R angle R. 2 root 65 is little r. So I've got to square it. 2 root 65 needs to be squared. Minus 2 lots of q, well q is this thing, 3 root 26, by r, that's 2 root 65, and just squeeze in at the end cos P. I'll leave it as P for the moment. Okay, let's just simplify things. Root 26, square it, 26. If you square this thing, square the 3, square the root 26, so you get 9 lots of 26. 3 squared, root 26 squared, so you get 9 lots of 26. 10 lots of 260, so 9 lots would be 234. Plus, square 2 root 65. Square the 2, you get 4. Square the root 65, you get 65. 4 times 65 is 130, 260. And then I've got a minus. Right, 2 times the 3 is 6, times the 2 is 12. I'll leave the root 26, root 65 alone, and I'll leave the cos P alone. So we get to that. Just tidy up these two numbers there. You get 26 equals 494 minus 12 root 26 root 65 cos P. The thing I'm trying to find is the P, obviously. That's in this quantity, which is a negative, so I'm going to take that quantity to the left. Notice I haven't worked out these surds as they stand. I'm not going to at this stage. going to take them to the left. You're going to get positive 12 root 26 root 65 cos p on the left, and you're going to get 494 minus 26, take that over, becomes a minus on the right. Okay, so the cos of p will be equal to, that take away that, you get 474,468, and then divide by all these quantities, 12 root 26 root 65, and there's the cos p value. Most people now would reach for the calculators, work that out, and then inverse cos it to get the angle P. All I'm going to do, because I haven't got a calculator to hand, is to say that the angle P, which they actually call, let's use their notation now, QPR. So we'll refer to it as QPR, Q to P to R, which is that angle, theta if you want, in my picture, is equal to, and I'm just going to say it's the inverse cos value of 468 over 12 root 26 root 65, like so. I'm not going to actually work it out in degrees. That would be fine. If you want to work it out in degrees, if you're more comfortable doing that, fine, work it out in degrees. Obviously sometimes it might actually say work it out in degrees, in which case you have to. It doesn't say that here, so you can leave it like that. That's the end of the question. The last part, as you can see, was in a lot of work for just 3 marks, and that's often the case in these sort of questions. The first 2 parts you get quite a few marks for very little work. The last part you get only a couple of marks for quite a lot of work. And there you go, that's the end of the question, May 2008 C2.